So let's just understand what is function. I have seen multiple students struggling with the definition of function, right? So what is function? You go to function, some events, and then there is a relation also. So what's the difference between a function and a relation? And I'll give you the easiest way to remember it. You will remember it throughout your life. I bet on it. So let's just quickly start. In your lower grades, you were fond of doing matchups or match the followings? Match up or match the following type of questions? I was very fond of it. So yeah, it was the easiest question. You don't need to remember any spellings, anything, just tuck, 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 and your life is sorted. So let's just start with the matchups only. Okay, let's say you have these two sets given. Let's say these are, okay, so this is your A, this is your B, this is your C, this is your D. This is your 1, this is 2, this is 3, this is 4. So you have some option A, option B, option C, and these are 1, 2, 3. Now I need to match it, right? There are different ways of doing it. Let's see how many ways we can do it. So A can go to 1, A can go to 2, A can go to 3, A can go to 4, right? So A can go to similarly option, let's say your option A is even numbers. So option number 1 says are divisible by 2, all the number divisible by 4 is option 2, all the number divisible by 8, option 3. So you can relate, right? So this is your relation. So now our relationship begins. Okay, now how this relation will function, right? Relation has functions. What are the different types? So let's just see what is the difference between a relation. Now I'm trying to catch up in a philosophical manner, but relation in maths just means to link. Simply how the elements are linked. How the elements are linked to each other from the first set to the second set. So relation can be in any format. Even if I skip B, C, D and don't link it, it's okay. First set is related to the second set in this manner. Okay, I don't have any issue with that. But what's the special thing about functions? And it's a very versatile thing. You must have seen your trigonometric functions in your lower grades, sine, cosine, cotangent, right? And you must have seen something like that, f of x is equal to 2x or y is equal to 2x. You must have drawn that straight line. You must have heard something like that. This is the function. There is a vertical line test. But what is it a function actually? If I'm given some the way something is written, how can I even see in air or visualize it what is function? I'll give you one way that will ease your life for sure. So let's see. First condition for a function. So I'll give you don'ts. The function that doesn't, if a relation doesn't follow this criterion, then it is not a function. Because if you know what is not a function, what is a function is really easy. Let's just, so let's see what is not a function. So I have this 2, 6. This is your A, this is your B, this is your C, this is your D. This is your 1, this is your 2, this is your 3, this is your 4. Okay. So if you are mapping in this format, A goes to 1, B goes to 3, and C goes to 4. And you're leaving one element over here. Let's say D is left out. If any element in the first set is not involved in the relation, then it is not a function. It cannot be a function. Okay. If the element of first set is not involved, oh wait a minute, is not involved in mapping. What does mapping means? Just what the match the following you are doing. No, the technical word is mapping for it. It's not involved in mapping, then it's not a function. So you got one thing, one result. So all the, you know what? All the elements in first set have a special name. That's domain. So all the elements of your domain or the first set should be involved in mapping. Even if you're restricting domain, it means you're squeezing it. But even the restricted domain, okay, all the elements should be involved of the restricted set where it is being restricted to. Now, second criterion. Have you heard about asexual reproduction? That a single parent reproduce into two. In the case of money plant, if you cut it, you plant the two parts of, let's say, even if you plant the leaf of the money plant, it will give you a new money plant, right? Even if you cut the starfish from the middle, it will regenerate and give you a new starfish, right? It will split it into two, like a money plant. I quickly tell you why I'm saying so, why I'm using this example of money plant, starfish. This type of reproduction is asexual reproduction. It's unlike to humans. In humans, you require two persons, right? A male and a female. So asexual reproduction is not possible. Look, I was making this diagram, the match the following. Okay. So this is your set A, this is your B. I'm giving A and B, right? Yeah. A, B, C, D. Here you have 1, here you have 2, here you have 3, here you have 4. So it will not, like there will be no case, let's say B goes to this thing, this is also used, this is also used, A is also used. But it can't happen that B can go to 2 or more than that. Okay. So this thing is not permissible in function. Look, B is going to 1 and B is going to 2. That's not allowed. So can I say B has 2 kids? Okay, let's say if the first set is your parent set. Right? So here you can't split it, it can't get split into 2. And each part will regenerate. A single parent, single kid, something like that. Okay. Just remember that it can't get split into 2 or 3. Okay, so if this is the parent set and this is the child set, this is not possible. Asexual type of thing is not splitting in 2 parts. That type of reproduction is not allowed. Okay, so you have A, you have your B, you have your C, you have your D, right? And here you have your 1, here you have your 2, here you have your 3, here you have your 4. So A going to 1, A going to 2, A going to 3, A going to 4. Okay, now B going to 1, C going to 2, and your D going to 4. All right. So look, A is involved with everything. So we can't have this. So what is the definition of the function? Okay. So now you got the cases which gives us that it is not a function. The moment you spot this, you say it is not a function. So that a single parent cannot have 2 or more kids. That's what your vertical line test is. If you plot a graph, if you plot a given function, right? Let's say if you plot a function like this. You know this curve, this is your parabola. And now if I do the vertical line test for this parabola, you can say if this x-axis is your first set and y-axis is your second set, right? So at this spot, it is getting mapped to 2 points, right? This one, and that's not permissible. Okay. But whereas if the parabola is along y-axis, then it's a function. Now one more thing is there. That's very important. We say all the elements of the first set gets mapped to the unique element of the second set, right? So where does this uniqueness come from? Because we have constant kind of thing also. So where does this uniqueness comes from? Let's see that as well. So here you have your A. Here you have A acquainted with the second set. No. So A can go to 1. So for A, the second set, all the element is unique. Yes or no? Yes. For B, all the elements are unique. For C, all the elements are unique. For D, all the elements are unique in the second set. It's almost like, let's say, I have a, let me take some names. Arpita, Ben, Chris, and Danish. These 4 students, they are going from first year to the second year, right? For them, the second year is unique only, no? Even though, let's say they had like Arpita is coming from the first to the second year in 2020. Ben is going in 2021. And Chris is going in 2022, 2023. Though their timelines are different, but they're going to the first, they're opting for this course. You can visualize like that. So the second set, they're not acquainted with the second set. So if we say all the elements of the first set is mapped to the unique element of the second set, uniqueness hold in this sense that for B, all the elements are unique. B has not met the elements of the second set yet. For C, this person, he or she has not seen the elements of the second set. It's almost like your sibling, younger sibling, you have gone from year grade 11 or year 11 to year 12, right? But if your younger sibling comes, for him, the courses are the same, the name is same, right? So mapping will be somewhat same. He or she will be opting for calculus, algebra, or any courses like that, right? So uniqueness holds in that sense that these elements have not seen the elements of the second set. Okay. So I hope you are able to understand definition of the function. It's just a one-liner statement. I have seen multiple books. I've read multiple books on books giving different types of definitions on function. Just remember, every mathematician who's writing book has a unique way of presenting it. So I've tried to club all the definitions and all the widely accepted definition. First thing is elements of all the first set should be involved in mapping. That's domain. Asexual reproduction, or you popularly known as a vertical line test. Asexual reproduction case, or the when you graph it, it's a vertical line test, right? That should be there. And your third, that the uniqueness thing, when we say all the elements of the first set should be mapped to all the elements of the second set. So uniqueness comes from where? Like if Okay, so it's about the acquaintance, that those elements are naive, they have not seen the second set, they have not seen that second world or the outer world, something like that. I hope you're able to visualize it. So yeah, that's it for today. I'll be coming up with the one onto many ones in the next